So I want to take some time very quickly to show a shortcut for checking the continuity of a rational function at a point. I'm specifically talking about our number 27 from our day 2 practice test problem. Okay, let me show you what I mean. I think I spent too much time talking about how you have to factor this rational function, the numerator, the denominator, and see if the factors cancel out or not, the zeros, and when you're looking for wholes or asymptotes. But there's a much faster way to attack these problems when we're talking about continuity. So essentially what we're going to do is we're going to take this point, x equals -1, and we're just going to plug it into the denominator, and we're going to see what answer we get. All right, so I'm going to plug -1 in, which would be -1 squared plus 2 times -1 plus 1. And when I multiply that out, I get 1 minus 2 plus 1, which is 0. Once you get 0, that's an indicator that we're going to have a discontinuity because we can't divide by 0. That function is not going to be defined there. The way you tell what kind of discontinuity you have has to do with what the value of the numerator is. So if you get 0 in the denominator, then you go and you plug that -1 into the numerator. So we're just going to plug in -1 to x, meaning we're just going to get -1 on the numerator. Oops, I made an 11 there. Let me erase that. We're going to get -1 when we plug it in, right? I plugged it in here and I get -1. That means that my total fraction for f of x, although we're not going to put equals, but essentially what we just got was -1 over 0. This indicates that we have an asymptote. If you study in Algebra 2, that's what we would say this is. Okay, we have a vertical asymptote. But in terms of continuity, what we know is that we have an infinite discontinuity. Discontinuity. Man, my spelling is bad today, just like my teaching. Okay, so we have an infinite discontinuity when we get some weird number, not 0, over 0. Anything but 0 over 0 is an infinite discontinuity because it makes a vertical asymptote. If you happen to get 0 over 0, that's a removable, and I'm going to show you that next. But plug it into the denominator. If you get 0, then check the numerator. If you get some number that's not 0, that is an infinite discontinuity, just like this one. Okay, let me show you a different kind of discontinuity. Again, we're going to start out this example by plugging -2 into the denominator. I get -2 plus 2 equals 0. That tells me I'm going to have a discontinuity. I just need to see what the value of the numerator is. So right now I have over 0 here. Let's check the numerator. For the numerator, I'm going to have -2 squared minus -2 minus 6. So this is going to be 4 plus 2 minus 6. That's also 0. So that means we have a 0 over 0 situation. Now, algebraically, that means that this x plus 2 is going to cancel, but we don't care. All we want to know is what kind of discontinuity this is. If you get a 0 over 0, we are going to put removable discontinuity. Because if I divide out the x plus 2 factor, I get rid of the discontinuity. So that's a removable discontinuity. 0 over 0 is removable. Okay? One more example, and then I'll just give you a brief chart and we'll be done. Let's try this one out. I'm checking two values. I'm checking -5 and 0. So we'll start with the denominator. Let's do x equals -5 over here. When I put -5 in, I get -5 squared plus 5 times -5. That's going to be 25 minus 25. That's 0. We have a discontinuity there. We'll check what kind it is in a minute. When I plug 0 into the denominator, I get 0 plus 0, which is 0. And so that is also a 0 denominator. That means we have a discontinuity there. Now, on top, for the numerator, I get -5 plus 3, and that's going to be -2. So this is a -2 over 0. That is an infinite discontinuity. And in the other one, when I do 0 plus 3, I get 3 over 0. So that's also infinite. Okay, I'm almost done. I'm going to just, on the next slide, summarize for you what to write down depending on what you get with your fractions. Okay, I just took a few seconds to scribble this chart out, but the bottom line is this. When we start these problems, we're going to plug the x value that they give us into the denominator. If I get a denominator that's not 0, I immediately say this thing's going to be continuous. There's nothing fancy about a rational function with a 7 in the denominator. If I get 0 in the denominator and then check the numerator, and I end up with some other non-zero number over 0, that's infinite. And if I get 0 in the denominator and then test the numerator and also get 0, that's removable. All right? That is a fast way for you to attack number 27. I've already talked too long, but if you still have questions about this, you know where to find me. In the meantime, take care.